Alright, so today's our last day of notes for this unit. I know that's very exciting. I'm very excited. I apologize. I am still a little nasally though. So we're going to continue on with 10.5. We're going to learn about the product to sum and the sum to product identities. These are on your packet of identities. So I'm not going to spend a ton of time going through them. You can prove them to yourselves using the sum and difference formulas and the double angle identities. Here are the product to sum. Those were the sum to product. Let's go right to the examples. So I want you to write the product as a sum or a difference. So here we have a product. I want you to write it as a sum or a difference and simplify as much as possible. I'm going to pause the video, or I want you to pause the video. I apologize. I want you to try to do that looking at and using those identities. So this is a product. We want to write it as a sum or a difference. And unpause it if you get stuck or if you're not sure what to do or when you're ready to check your work. Alright, so first I'm using the product formula for sine of A times sine of B equals 1/2 cosine A minus B minus cosine of A plus B. So that is this identity right here. This is what I used. And so I just plug this in. So A in this case is theta plus pi, B is theta minus pi. So I plug it into the formula. When I simplify the left-hand side and distribute the negative, this ends up being just the cosine of 2 pi. When I simplify the right-hand side, and this ends up being just the cosine of 2 theta. Cosine of 2 pi is 1, so when I distribute the 1/2, that just becomes 1/2, and here I get 1/2 cosine of 2 theta. If I combine this into a single fraction, I end up with 1 minus cosine of 2 theta over 2, which is my power-reducing formula for sine, so this is sine squared. Bet you didn't see that coming. Next one, I want you to write the sum as a product. So here you're given sine of x plus sine of 5x. Write the sum as a product and simplify. Okay, so here I'm using the sum formula for sine to write sum to product. So this is this identity right here that I'm using. So I just plug it into that formula. 2 sine of x plus 5x over 2 times the cosine of x minus 5x over 2. X plus 5x over 2 is 3x. X minus 5x over 2 is negative 2x. Even odd identity tells me that the cosine of negative 2x is the same as the cosine of 2x. So my final answer is 2 sine of 3x times the cosine of 2x. Next one, I want you to solve between 0 and 2 pi, so you're looking for specific solutions. Cosine of 2x minus cosine of 6x equals 0. I will give you a hint. I would use the sum to product identity. Pause the video, unpause when you're ready to check your work. Alright, so I can use the sum to product identity, and the cosine of 2x minus cosine of 6x becomes negative 2 sine of 2x plus 6x over 2 times sine of 2x minus 6x over 2. Negative 2 sine of 2x plus 6x over 2 becomes negative 2 sine of 4x. 2x minus 6x over 2 becomes sine of negative 2x. Sine of negative 2x, using my even-odd identity, I can pull the negative out front, and this whole equation becomes 2 sine of 4x sine of 2x equals 0. Since this is all a product, I can set it equal to 0, so sine of 4x equals 0 and sine of 2x equals 0. Because this is a 4x, I have to go around the circle 4 times. So 4x equals 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Because this is a 2x, I have to go around the circle twice. So 2x equals 0, pi, 2 pi, and 3 pi. Now, to get all of my actual x values, I'm going to divide all of these by 4 and all of these by 2. These values over here are going to become redundant, these values here. So they actually, I get all of the answers from just dividing these answers by 4. So in the end, x equals 0, pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, and 7 pi fourths. Next one, I want you to verify the identity. Sine of alpha over 3 times cosine of alpha over 3 equals 1/2 sine of 2 alpha over 3. Again, a hint is to use your product to sum identity now. So pause the video, unpause when you're ready to check your work. Alright, so on the left-hand side, if I use the product to sum identity, The sine of alpha over 3 times the cosine of alpha over 3 is the same as 1/2 times the quantity sine of alpha over 3 plus alpha over 3 plus sine of alpha over 3 minus alpha over 3. Sine of alpha over 3 plus alpha over 3 is sine of 2 alpha over 3. Sine of alpha over 3 minus alpha over 3 is the sine of 0. The sine of 0 is 0, so this just becomes 1/2 sine of 2 alpha over 3, which is 1/2 sine of 2 alpha over 3. Alright, here I want you to again verify the trig identity. Again, here my hint would be to use the sum to product identities. Pause the video, unpause when you're ready to check your work. Okay, so on the left hand side, the sine of x plus the sine of y is 2 sine of x plus y over 2 cosine of x minus y over 2, and the cosine of x minus the cosine of y is negative 2 sine of x plus y over 2 sine of x minus y over 2. So the 2's, now this is all products. So the 2's in front can cancel, and sine of x plus y over 2 over sine of x plus y over 2 cancels. So I'm left with negative cosine of x minus y over 2 over sine of x minus y over 2. Since the angles are the same, this is my quotient identity, cosine over sine, which is cotangent, so I end up with negative cotangent of x minus y over 2 is negative cotangent of x minus y over 2. Next one. I want you to verify the identity. Cosine of pi thirds plus x plus cosine of pi thirds minus x is cosine of x. Use the sum to product identities. Pause the video, unpause when you're ready to check your work. Alright, so here cosine of pi thirds plus x plus cosine of pi thirds minus x is 2 cosine of pi thirds plus x plus pi thirds minus x over 2 times cosine of pi thirds plus x minus pi thirds plus x over 2. The pi thirds plus x plus pi thirds minus x over 2 all simplifies to just pi thirds. Pi thirds plus x minus pi thirds plus x over 2 all simplifies to just x. So I'm left with 2 cosine pi thirds times cosine of x. Cosine of pi thirds is 1/2, so 2 times 1/2 is 1. So I end up with cosine of x equals cosine of x. I do want to point out this is not the only way to do this identity, or to verify this identity. Just like with a lot of these problems, and I've mentioned this before, there are other methods you could use. For instance, you could have used the sum and difference formulas here as well, and it'll still work out that you end up with just cosine of x. Alright, last one. Write this trigonometric expression as an algebraic expression. What does that mean? Remember, that means that we don't want to have any trig functions in our expression anymore. So pause the video and see if you can figure out how to do this again, or not again, but as in before with problems like this, drawing a triangle is very helpful. Okay, so we should end up with 2x squared minus 1 as our algebraic expression. Now if you're confused on that, let's go through the explanation. Alright, so first we want to remember arc cosine of x. That's the same thing as saying arc cosine of x equals some theta. Because arc cosine of x, that trigonometric expression represents an angle. I'm calling that angle theta. If arc cosine of x equals theta, that means cosine of theta has to equal x. Here would be my triangle for theta, where the adjacent side is x, the hypotenuse is 1. Okay, so now remember this whole piece is theta, so cosine of 2 arc cosine of x is actually saying the cosine of 2 theta. The cosine of 2 theta is 2 cosine squared of theta minus 1. But what is cosine of theta? Cosine of theta is x. So cosine of theta becomes x. So since it was cosine squared theta, this becomes x squared, so I have 2x squared minus 1. So that is my algebraic expression from the trigonometric expression. Alright, so what do we want to make sure we take away from this unit? We want to take away our trig identities. We want to know them, love them, respect them, because you never know. Someday they might save your life.